Hello all, welcome to my channel. And in today's session, we are going to discuss a concept which was pointed out by one of my viewers. He wanted me to discuss on demand paging and also to discuss a GATE previous year question with that. So here I am. So I'm just going to discuss the concept briefly and then we are going to attempt a previous year question and we're going to see how we solve that. Okay, so now paging. What is demand paging? So it is basically a method of virtual memory management, and the concept behind it is that in such a system which obeys demand paging, what happens is that operating system copies a disk page only when it is required by any process. Okay, so only if an attempt is made to access it and the page is already not there in the memory. So basically, what is the basic idea that I've just jotted down on the basis of my understanding? So here is the idea. So let's suppose there is a process in our memory and it is executing and it is requesting some information which is present on page 8, page 3. Okay, so now operating system will what it do, it will first check whether the page is present in main memory. If it is present in main memory, it will provide that information to that process. Now if it is not present in main memory, then it will load that page from secondary memory to the main memory. Okay, but the important point over here to note down is that operating system does not initially load all the pages into the main memory. So it loads only the pages which are requested by the running processes and on the demand of those processes. So that is why the name is demand paging. The pages are loaded only on demand of the processes and only when they are demanded. So that is why it is also known as lazy loading or lazy evaluation technique. Okay, so this we have already discussed. Now the implementation which is used to implement this technique is a page table. So we basically use a page table which is nothing but a mapping between those pages and the frames. As we all know that page table, so as we all know that there are two kinds of memories whenever we talk about some storage or anything. There is one is main memory, right, and the other one is the secondary memory. Now main memory is also known as the logical memory and the secondary memory is also known as the physical memory. Now the pages, the information is represented in the form of pages. We say there is the data is present in the form of pages in the logical memory or the main memory and in the form of frames in the secondary memory. So the page table, what it does is it basically maps these two things, pages and the frames. So if I just have to write implicitly, it will be like this. So there is a mapping between, it will say that this information of PI page is present in frame FJ in the secondary memory. So this is the frame which corresponds to this page from among these two memories. Now also there is one additional thing over here, which is that the pages, they also have a one bit which is valid or invalid bit along with them. So every page has a valid or invalid thing along with it. So valid or invalid bit. So this is just one bit which you can say is either 1 or 0. You can say it is represented in the form of this. Now 1 represents valid, 0 represents invalid. Now what does that mean? Now this is to represent the status of these pages. So if the bit is set to 1, which is valid, then we say that the page is present in main memory, and if it is invalid, then the page is in secondary memory. So whenever a process requests a page which is not present in main memory, we say that a page fault occurs. So that is the concept of page fault. Okay, and then to service that page fault, what the operating system does is it loads the frame from loads the information from secondary memory to main memory. So that is the basic notion behind this. And also now, what if the main memory gets full? I mean, in this process, what if the main memory capacity gets full with the pages, and a new process comes which requests a new page which is not currently present in main memory. In that case, the role comes of the replacement algorithms, right? The replacement algorithms like first optimal replacement algorithm, or you say least recently uh, used algorithm, first in first out, all those algorithms, then you use those algorithms to replace an old page with a recently requested one. Okay, now which one is to be replaced, that depends again on the replacement algorithm. So this is a brief description of entire thing, and now we'll study how and what kind of questions do we get in GATE and how do we solve them, right? So this is one of the questions pointed by that user. Now this is from GATE 2007, but it is a very relevant and appropriate question to this concept. So I'm discussing this. Yes, I'll post some recent questions also with this topic from some recent GATE question papers. So for now, let's just discuss this and let's see how we solve this. It is a very simple question. So if you know the concept, it is very simple for you to solve this now. Now it says that a page has been allocated 3 page frames. So there are 3 page frames, okay? Assume a process has been allocated 3 page frames. Assume that one of the pages of the process are available in the memory initially. Okay, sorry, so sorry about it. It says assume that none of the pages of the process are available in the memory initially. Then the process makes the following sequence of page references. So this is the references that the process is making. So it is requiring these pages in this order. Then they have asked that if first question is, now this is from the linked kind of questions. First question is, if optimal page replacement policy is used, how many page faults occur for the above reference string? Okay. Next is least recently used page replacement policy is a practical approximation of this of optimal page replacement. For the above reference string, how many page faults are there with LRU? So they are asking basically the number of page faults. So how many more page faults? Important thing over here is how many more page faults occur with LRU than with the optimal page replacement policy. Okay. So now this is very important that you read the question clearly. You read the question with full attention, because a slight difference in reading the question can, result in negatives. So let's start with this question. Let's start with 82 question first, and let's see how many page faults we get when we solve this using optimal page replacement policy. So first of all, yeah, there is none of the pages are there in the memory initially. So this is what I've drawn for 3 page frames, 1, 2, 3. Okay. Now I insert, when it asks for 1, I simply fetch 1 and I insert it over here. Okay. Then it asks for 2. Again, 2 is placed over here. Then it asks for 1. So 1 is already there, right? And then it asks for 3. I place 3. So far there have been 3 page faults, right? So what if it will be better, I think we keep on writing the page faults also somewhere. So when I added 1, 1 plus for 2 plus for 3, right? And for the second request of 1, there was a page hit. Okay, so the page fault didn't occur over there. Then now when 7 comes, then we'll have to think about the replacement, right? Page replacement. Now in optimal, what is the basic logic behind optimal is you replace the page which is not going to be used in future, in the near future, I mean which is going to be least number of times it is going to be used in future. Okay, which is going to be used the least in the future. Okay, so now I'll just see over here, and when I see and analyze over here, I see that 2 is never being used, so I'll replace 2. Okay, So I'll replace 2 and I'll put 7 over here. And with the addition of 7, there was another page fault because 7 was not there in the memory. Okay. Now we move to 4. Again, we'll have to replace 4. Now I analyze this sequence and I compare it with the future thing which is over here. Now I compare it over here. I compare it over here and I see that 5631. 5631 is there. So 31 is there, 7 is nowhere there. So we are going to replace this with 4. Again, one more page fault for this 4. Okay. Next comes 5. Again, we have 3 and 1 being used in future but not 4. So we are going to replace this 4 with 5. And again, one more page fault is going to occur with this. Again with 6, same thing, 3 and 1 being used in future. So what are we going to do? We are going to cut this. We are going to write 6 and one more page fault. Then 3 and 1, there is a page hit, no page fault. So we are just going to total up the page faults that have occurred. 1, 2, 3, 4, 5, 6, 7. So there are 7 page faults over here, which marks the answer as A part. Okay, so A part is the answer over here. Now let's see the 83rd question. So I'll just erase this thing. Yeah. And we'll solve the 83rd question in the same manner but using a different algorithm. Okay. Now over here we have to use the least recently used page replacement policy. So let's check with this. First of all, in the same manner, what we are going to do, we are going to insert 1 and 2. 1 and 2 I've inserted, so 2 page faults for this. Then 1 again, so a page hit. Then 3 I'll insert in the same manner, 3 page faults. Then 7. Now when I insert 7, I have to replace the least recently used, right? Least recently used page. Okay. So there is a difference between least recently and most recently used. Now which one is the most recently? I've just used 3. So this one is the most recently one. And least recently one is which one was the oldest page that you used. Now important thing over here is the oldest one which you used, not the oldest one which you inserted. Okay. So now if you just think about this, you may say that one was the page which was inserted in the beginning, but no, it is not the least recently used. Okay, so 2 is the one which is being used. 1 was just used before 3 if you just pay attention to this order. Okay, so over here the frame which was least recently used is 2, so we'll cut this over here and what we'll do, we'll insert 7 and again a page fault occurs because of this. Okay, now next we move for the next one, which is 4. So in case of 4, what will happen? Again, we'll have to replace something. So again, you see, basically the best part to solve this question is you see in this direction now. In optimal, we saw in this direction. Okay. So now when I see in this direction, uh, I am here to replace something for 4. I am over here. I am focusing on this. So now 7 and 3 have been just used. So 1 is the oldest one over here. So we'll cut this and I'll mark 4 over here. And this is one page void because of this 4. Okay. Now for 5, 4 and 7 have been just used. So we are going to replace 3 by 5 and add the page fault. Again, now with 6, 4 and 5 just used, we are going to replace 7 with 6, add the page fault count. Similarly, 3, so 6 and 5 being just used, so we are going to replace 4 with what? 3. And we are going to add the page fault count over here, let's say. Then the last one, 1. So 6 and 3 just used. We are going to replace 5 with 1. And I'm going to add the page fault count. So when I now total the page faults, I get 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, 9. So 9 page faults, right? Also, if you just want to verify, you can, check with the cut marks and the number of elements inserted. So just 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 9 is the count over here. Now they ask the difference between 9 and 7. So the difference is 2. So the answer is here C part. So that's all for this particular question and this particular session. I'm going to be back with some more useful, knowledgeable questions. You can also let me know some of your doubts or some of the topics you want me to discuss by specifying them in the comment section below. Also, don't forget to like the video and subscribe to my channel if you want to view more videos of such type. And also, please press the bell icon so that you get notified every time I post a new video. And I'm really grateful to you for making the reach of this channel to 10K subscribers. Thank you very much for increasing our family count to 10K subscribers. So really grateful to you. Thank you. Please be safe and keep learning. Thank you.